Well, hello everyone. Happy Tuesday. I hope all of you are having a great day ahead of you. We wanted to get started with our first LinkedIn Live as well as a YouTube Live, which is getting streamed at the same time. So I'm extremely excited to have Roberto with me, who's a applied AI engineer from our team. And this is going to be our first live. And we hope to do more of these just to get you excited about the latest that's going on, like doing these sort of deep dive sessions, helping you break through some of these topics which are happening right now in the AI space, give you some more deeper insights into these models, how they have been built, give you insights about the use cases, and also share some hands on demos that you can replicate and get started to build it together. So, without much ado, let's get started. And we just have 30 minutes of time, so we have a lot to cover today. So, we're going to start with talking about the architecture of these new models that has been launched by OpenAI. There's two versions of them. We'll get into the details of it, but it's called GPT-OSS. OSS stands for open source. And then we're going to get into something very cool. We have built a tool called chat.fireworks.ai, and we're going to walk you through the demo for that. And it's an amazing tool. It's a very handy tool if you're an AI engineer building and experimenting with different models, trying to compare them. That's a great tool and will come handy. And then finally, we'll show you a demo that Roberto has built. And at the end of the session, we'll have some time for question and answer. Now, before we get started, just a quick introduction about us and what we do here at Fireworks. If you're not familiar with Fireworks AI, it's an inference engine and it's one of the fastest inference engine for open source generative AI models. We have a large suite of models. We have over 1,000 models that we support on the platform. Everything from Kimi to Quen to some of the open source models from OpenAI. And then we have some stable diffusion models. We have the DeepSeek models. So we support a wide variety of open source models on our platform. And one of the USPs that we have is we serve it with the lowest latency without compromising on the cost and with optimized, without compromising on the speed with optimized cost. So if you look at any of the benchmarks, you will see Fireworks up top with the best performance for these models. So Roberto, let's get started, and would love to introduce yourself, and yeah, we can get started.
Yeah, thanks, Aish. Yeah, I mean, excited to do this. Also my first webinar ever. It's weird because I don't see people. I'm used to seeing all of the lovely faces. So I guess it's kind of cheating because that way you don't get nervous. Anyways, yeah, I'm Roberto. I'm in the applied AI team here at Fireworks. I work very closely with our engineering team as well as our sales team and our partnership team. And super excited to talk about the new OpenAI OSS models. I think they have a lot of very interesting use cases, and they're a really cool addition to the open source model landscape.
Amazing. Okay, so let's get started then. So
Yeah, so I think maybe we start just with like a very bird's eye view of the OpenAI models, right? So everybody knows OpenAI. I don't know when it was that they released ChatGPT, and that was kind of like the birth of this entire industry, which is kind of wild. But even before they released ChatGPT, they actually had GPT-2, which was in 2019, I believe. So since then, GPT-2 was open source, by the way. Since then, they have not released a single open source model up until now. So, the common joke is, well, they're not very open, even though they're called OpenAI. Now, I guess they are open again, which is incredible because they have like top quality researchers and everything they do is really good. So that's a little bit of context, right? From 2019 to 2025, a big gap, but now they're back in the open, actually open, no pun intended, on the OpenAI game. So here, what we're looking at, this is just a slide that we put together here at Fireworks on GPT OSS. This is the 120B model. And you'll see across all of these benchmarks, both the 120B and the 20B, those are the yellow and oranges, they perform incredibly well, right? So for complex tasks like math, like PhD science, like agentic use cases, tool and function calling, etc., they perform as well as like closed source models from OpenAI. So you can see, let's say AIM 2024, which is a math competition. I mean, they're even better, right, than O3 and O3 Mini. And basically the same than O4 mini, and you'll see that across most of these benchmarks. And if you take a step back, it's wild how fast like the industry develops and advances, because right now you see this benchmarks and you're like, oh, cool, whatever. But when O3 released, right, a couple of months ago, maybe less than a year ago ish, it was an insane model, right? So now we have O3 level intelligence open source that you can actually run on your laptop, or if you have a 20B, even on edge devices. Yeah, so it's pretty crazy. In terms of the actual architecture of the models, baseline, or rather the superficial points of looking at in terms of the architecture is, of course, like how many parameters that they have. So it's a little bit of a misnomer, because they say 120B. In reality, that one has 107 TBs. Round up, because if not, it would be a weird name. And then the 20B actually has a 21B. Also, I guess round down, because if not, it would be a weird name. But the important thing here is, as the trend in the industry, these are mixture of experts models. So this is like common standard of architecture in the industry at this point, which means that they basically have like smaller, you can think about like smaller submodels within them. Each is an expert that becomes very, very good during the training phase at specific use cases or at specific tasks. The 120B only has around 5 billion active experts, and then the 20B has around 3.6, almost 4 billion experts. And then both have the same token length, which is cool. In terms of the architecture, so I don't know if anybody on the call knows this, but Sebastian Rachka, who's an AI researcher, was phenomenal. His content is phenomenal. He released a really good deep dive into like the architectures of these models and comparing it to GPT-2 as well as the Qwen 3 family. The TLDR is that there are differences, but it's not huge differences, right? So the differences, I think, would be, one is that they're optimized very smartly to run on FP4, which is a type of optimization, basically quantization from FP16. You have all of your float numbers, and then you go down less precision, right? That is one change. They also made it really, really memory efficient through this quantization to run on hardware. So instead of needing, a ton of GPUs to run any of these models, both of them can run, the 120B can run on a single GPU. So you're not like as memory constrained as before, which is very, very exciting. It essentially democratizes open source AI for anyone, right, that wants to run them without having like too much of a budget to deploy to multiple GPUs. And then the other thing I'll mention, and then I'll shut up, Aish, I promise, so you can ask any questions, is what's really cool as well is that this is the first release of open source models from a US-based company since the Llama 4 models were released. And, like Facebook is definitely, I would say, probably they were the people that started the open source with their first Llama release. So, huge kudos to that entire team. And then lately, in the past couple of months, it's really been the labs out of China, DeepSeek, Qwen, now Kimi, who have been absolutely crushing it. So it's exciting to see, OpenAI get back into that game. So that is my spiel. Aish, any specific questions or things you want to go into?
Yeah, let's probably talk about some of the use cases. I know, like, we've spoken about benchmarks, and just today we released our new blog, which was talking about the function calling benchmarks for the model. It was apparently underreported by 5 to 10%. So let's maybe talk about the use cases and what really sets the model apart. What are some of the models in the current pipeline that people might be using, and for whom would this model be a really good switch? So let's talk about that and like maybe get into the details of what sort of use cases would they be covering.
Absolutely. Yeah, I mean, I think one thing that's super important about this model is that it performs really well. And I know this at this point, this term doesn't mean too much, but I'll try to be specific when I say it, at agentic use cases. And by that, I mean specifically at using tools to gather external information, right? So we're all familiar with function calling, tool use, whatever you want to call it. And both of these models, the 120 and the 20B, are really good at knowing when to call a specific tool to get external information. So knowing that in the background, this then, and you can infer that good use cases for this are definitely in like the enterprise or business specific context, right? So we're thinking like healthcare, FI, like financial services industries, etc., where you can actually connect a model to external data that it can pull in order to basically give you the final response. I will say, like, there are some limitations of these models. One of them, if you search for, in Reddit, deep in the subreddits of LLMs, and I actually checked this, and I'll show you guys in the demo, is if you want it to just respond based on like the training data that it has, they might not be as good, right? Because their training data might not be as updated, and they were trained specifically for this like business or startup specific use cases. So I think that's one thing to keep in mind. The other thing that's really important is data privacy and cost control. So having a model, right, this size that you can actually fine tune yourself, and I don't want to do a shameless plug, but at Fireworks, we're actually terrific at fine tuning in terms of supervised fine tuning and reinforcement fine tuning. But even if you're not running on Fireworks, being able to fine tune your model specifically on your specific data and make it so that these models are not, miles wide, inch deep, but rather they're miles deep, inch wide, is super powerful. And you can do this with the OpenAI models. So for your specific business use case, you can turn it into much better than even like the leading proprietary closed source models. So yeah, I'd say that would be my answer. To recap everything, the TLDR is definitely use cases where you can set up external tool use or function calling, and then specifically around like business specific use cases,
Yes.
such as something in the FSI, let's say banking space, maybe a chat RAG retrieval use case where you can pull things from a vector database, etc.
Yeah, absolutely. There was also a cookbook that we had published around text to BigQuery query language. So that was also like pretty impressive because it has instruction following capability pretty well. So if you're trying to restrict it to output in a certain format, that it does pretty well. On top of that, we also offer grammar mode, which helps us like have a constrained output in terms of JSON when we're using it in those agentic workflows, which was pretty impressive. Um, Again, like with the Reddit threads that I have gone through, it seems like a lot of people are also experimenting it from a coding perspective. So Quinn 3 Coder is of course like one of the most popular models in the recent times that was launched recently. But also I've heard like a lot of people are testing out the 120B for coding assist, which seems to be performing really well. So that's another something that if the listeners are like working on some of those use cases, this might be quite a good model to test out. Um, Maybe one additional thing is let's go to the next slide, maybe. Before we get into the demo, I just wanted to address that the other model, the 20B variant, is also pretty powerful. And whenever you're building these workflows which require different level of complex tasks at every given point in time, using a larger model and a more efficient model for certain tasks versus using a smaller model which can handle less complex tasks but still give more accurate responses, in those situations 20B is also a very good option that you could use in your workflows. So just wanted to add it.
Yeah, that's actually an excellent transition. And for people on the line, I promise we actually did not plan this. So this is just a happenstance and good luck, because that's a great transition to the demo.
Yeah.
Because I actually used both models, specifically as you talked about, Aish, where one model, when you want something much quicker and it's a simpler task, it's better to use a smaller model. When you want something that's, maybe an orchestrator or a final answer that has to compile all of this information and give you a final answer, then you maybe want a more powerful model, in that case, the 120B. So anyways, let me paint the stage a little bit, and then I'll show you guys the model, the demo live. It is open source. It's on Hugging Face Spaces. So anybody on the line can actually check it out, see the code, repurpose it for their individual use cases or projects, etc. So the context is, the Federal Reserve has been, I'm a economics wonk, and I just very interested in it. And the Fed has been in the news lately quite a lot. Whether inflation is rising, it's not rising. What are they going to do? Whether they're going to increase interest rates, they're going to lower interest rates, they're going to stay the same. All these different things is always in the news, right? And the Fed actually, oh, sorry, this is just a tiny bit of a digression. The Fed has these things called the FOMC, Federal Open Market Committee, which are just these meetings where all of the governors of the Fed basically meet and they make a decision on whether they're going to increase or decrease interest rates. And of course, if they increase interest rates, then that has a repercussion on everybody, right? Mortgages go up, bank interest rates go up, etc. So if the economy is very hot, they increase interest rates. If the economy is slowing down a lot, then they lower interest rates. That's like the TLDR there. So I wanted to build a tool with OpenAI OSS models where I can basically use it to understand these like super complex FOMC meeting minutes that they release. Each one of them is like 18, 20 page PDF with like jargon that's very, even me, I have an undergrad in econ and I still don't understand any of this, pardon my language shit, but I wanted to understand it, right? So I want to get an idea. So anyways, data pipeline, right, which is the powerful thing about LLMs, is you don't have to use them for chat applications only. You can actually use them as well in like the standard data engineering ETL extraction type architecture. So here what I did is I built this FOMC data pipeline. We basically pull these 18, 20 page PDFs from the Federal Reserve's website. Then we use our trusted, beautiful soup in Python in order to basically scrape them, get all of the information, get the PDF link, etc. Then we use a Python package to do the actual text extraction. We get all of that content, and then we run it through the OpenAI 20 billion model through Fireworks AI using structured outputs in order to extract like the most important information, which is what was the decision? What is the forward guidance? Forward guidance means what is the Fed saying is the future of the economy in the next 6 months and what they might do in the future. So that's forward guidance. By the way, forward guidance literally moves markets entirely. So people like study this to understand whether they should do, large investments or not. And all of this is we use the 20 billion model to basically extract that all of the information, even in a simple data store, which is just a JSON, and then give that to the overall chat or Fed Savant tool, I call it, as the context for it to answer questions. So any questions on this setup? And if not, I can actually show the demo.
Let's go into the demo. I'll stop
Cool.
my screen so you can get started.
Yeah, give me 1 second. All right. You can see my screen, right? Okay.
You can see us.
Great. Okay. So, yeah, the front end is lacking, so please forgive me. I am not a front end engineer, as you can see. But I think what's important here is, the content that we're generating, which is very cool. So as I said, right, let me just show you Federal Reserve monetary newsletter, right? So this is like the Federal Reserve's website, right? It's a little clunky, etc. And then the actual PDFs, I'll show you one, are quite complex. What I did is I ran it through the data pipeline, right? And you'll see here, it's basically loading the summary of all of them. And let me open this up real quick. So this is what like the raw PDF looks like, right? 18 pages of very dense text. You guys can see this is not the easiest read in the world. We process them through the 20 billion model on Fireworks, and we extract all of this information, right? So when was the meeting? What was the action? Maintain means there wasn't any change to the interest rate. This is the interest rate. Of course, if there wasn't any change, the magnitude is zero. And then the forward guidance that I was talking about, as well as key factors that they are stating for their decision. So the latest one in June was, inflation remains above the 2% target, even though the economy looks okay. We're not going to lower interest rate just yet, as well as some economic outlook. So here we basically convert this 20-page PDF into a bite-sized summary that is objective based on the Federal Reserve's information. Again, this is important because you don't want to ask the model directly, like, what do you think about the Federal Reserve? Because it might hallucinate, it might make things up. But here, we're giving it all of the context directly from the Fed. So it's a very trusted source. So that's one thing, right? You, of course, can do, you can search for different things. So if you wanted to see the 2024 meetings, then you can search for them here and see what they did in 2024. So that's part of the data pipeline. And this is like the summary of that data pipeline, right? Now, of course, no demo is a good demo if it doesn't have a chatbot. So I also did a chatbot, which I think is very cool. And what we'll start with is, maybe I'll just say the simplest part, which was what was the rate decision in the last FOMC meeting? And then wait 1 second. We'll see here that I actually connected it to different tools, right? So we see after it stops streaming that it's saying here, hey, I am using a tool. This is an actual Python function in the code that is called get latest meeting. So essentially, I provided the LLM information on what functions it can use, what parameters to those functions. And then the LLM is reasoning. That's another thing to mention about these models. These are reasoning models. Is reasoning and saying, hey, they're asking me for the last FOMC meeting. Let me actually get that from the data. You run it, you get the actual data, and then that is what is provided to, you have an orchestrator LLM, and then you have, your chat LLM or response generator. So the orchestrator agent decides which, if any, tools to call, generates that call, runs it, and then gives that information to the response agent. The response agent, here it says, rate decision in the previous one, no change. Here's the forward guidance, and more information afterwards. Another key thing in all of these use cases, especially in, let's say, financial industries, is you want sources, right? So we also set up this demo so that it provides the direct sources that it's using. Again, the very long PDF. And then I'm just going to do one more example here because I do want to go through another demo comparing the OSS models to some of the previous models like Kimi. But let's say one more complex one, right? Let me just do a follow-up here. So this information is, digestible, but still somewhat difficult to understand. Just going to do a quick follow-up and tell it, like, can you explain the forward guidance of that meeting? And use Eli 5. So Eli 5 is explain it like I'm 5, right? And then this is super useful, right? So it's gonna grab what it showed me before, and then it's actually automatically figuring out that a thermostat is a good metaphor, right? So it's thinking, okay, thermostat is a good metaphor. If the thermostat is really hot, then it means the economy is running hot. Then the Fed would probably increase rates. If the thermostat is low, it means that it's cold. So it is pretty smart of the model. And then it explains it in a pretty simple way, right? So Fed's wording, we'll keep watching the data and act when needed, and then what that really means. We'll keep the balance sheet run-up schedule as is, and what that really means. So this is super useful if you want to digest Fed information like I do. If you're that big of a loser and a nerd, then this might be a handy tool. Now, the last thing I want to do, and then we can jump to another demo, is I want to tell it to give me a table which summarizes the last 5 FOMC meetings. And again, here it's going to run a couple of tools. So it's deciding to use some tools, run those tools, and then use that information and gather it in order to provide the final answer. And you see automatically, it gives me all of the sources for the past 5 meetings, which is really, really good. So in the case that I want to dig deeper, I can just click on those links. And then it is going to give me a summary of all of these things. So here you go. Here's like the full summary. We don't have to go through it, of course, but that's very powerful. So anyways, check it out. The good thing here, everything is running on Fireworks AI, so you get blazing fast inference. We're using structured outputs, we're using function calling, and we're using both the 20 billion and the 120 billion model. Cool? Anything further on this demo? If not, I'm happy to show one more that I think is super interesting.
Yes, let's go ahead with the second one.
Sounds good. All right. So as Ash mentioned before, we do have a tool called chat.fireworks. Very original name, I know. And here, what you can do is you can compare any of our serverless models to each other for your specific use case and get a quick gut check on which one might be better. So I prepared a couple of prompts to kind of like do almost like an eval of these different models and see how they perform, right? So let me start with a general knowledge one. So I said before that one limitation of the OpenAI OSS models is that they might not be trained with like super up-to-date information. So let me just ask it a question about the Nobel Prize in medicine, right? So here I'm saying, can you tell me about the 2024 Nobel Prize in medicine and give me some details, which institutions they're affiliated with, practical medical applications, etc. I'm going to compare it to Kimi K2, which is another top-of-the-line open source model that was recently released. And let's see what they say. So we see the 120B model is really fast, of course, because it's a much smaller model than Kimi K2. But then let's finish Kimi K2 and see if they were accurate or if they were not. And this is like a general knowledge hallucination test, right? So you see automatically that the OSS 120B model, it actually doesn't know, right? It doesn't hallucinate, which is good. It's telling you, hey, I don't have this information, but potentially you can check here. So figure it out. And then Kimi actually does have that information. Presumably it was trained with open source data that has specifically this information. And I actually checked this. Again, I'm very interested in The life sciences, so these are the you can Google it if you don't trust me, but these are the actual winners, and it is around mRNA, microRNA. So super cool. Now that's one. Let's do one more, which is reasoning, right? So these are reasoning models, so they're very good at following complex step-by-step reasoning and figuring out solutions. So here I have this like little um, mind game, right? Which is I have a 12-liter jug and a 5-liter jug. I need to measure exactly 6 liters of water, and the jugs have no markings. So there's an unlimited water supply. What is the process of using both of those jugs in order to measure exactly 6 liters? And let's see how they perform. Now, actually, I did this one before, and it took me a while to figure out if either of this work, because it's not that easy to actually think about like how you would do it. But you see, one thing is like the OSS models are a little more verbose than Kimi, but at the end, you'll see that the 120B model provides a really good reference, right, of like the process that you would do. And again, you can trust me, I actually went through this, something similar like this, and it did get it right. So two prompts that I just went through, right? One, general knowledge hallucination test. The OSS model didn't perform so well. Second one, reasoning. The OpenAI model performs really well. And then the last one I want to do is a coding example, right? So again, Aishu mentioned that they're very good at coding, which they are. They're also very fast. So let me compare, let's say instead of Kimi, let's try Llama Scout, right? So here I'm going to say Python function to find, this is a classic, lead code question, which is Python function to find the longest palindromic substring in a given string. And then I'm just giving it more details about like PEP8 conventions, BA Pythonic, et cetera, et cetera. So let me see how they perform. And then you'll see, well, Scout is still going. So let's wait a second for Scout to finish up. But one thing that you'll see with the OpenAI OSS model is it's really good at following instructions, right? So I told it a very detailed thing, Pythonic style, include comprehensive doc strings, variable names, all of these different things. It automatically gives me the function. Again, I tried this before and ran it in a Python console and it got it correct. And then it gives me how it works with very good detail. While Llama for Scout, it does a decent job, but not as good as it's not as good as like following the specific instructions that I sent. So anyways, I think it's super cool. You should definitely test it out yourself for your use cases. We have a lot of options here. These models are incredibly powerful for reasoning, function calling, instruction following, etc. And they have some limitations as other ones, but super excited about both of these releases and really excited to see what people build with these models on Fireworks.
Amazing. So, Roberto, I actually have a couple of questions for you with respect to the OSS models, right? When you've been trying to use different models, like what would your recommendations be for people who are testing out new models? And every time there's a new model that comes out, this week, just like in the last week, we have had at least like 4 to 5 models come out. If you look at the benchmarks, it's very hard to really understand, is 90, how much is 90 better than 89, or like how much is
Mm-hmm.
95 better than 92. It's very hard for people to understand that incremental increase in these performance for the benchmarks. So what would you recommend if people were to compare multiple different models, and if I already have, say, a proprietary OpenAI model running in my pipeline, how
Yeah.
would I test it out with these new open source models which are coming out and keep that experimentation pipeline alive to test out the new models but not overdo it and not like not swap out the models in production all the
Yeah.
time? So have my pipeline which is robust and at the same time like go test out different models. Like what would your recommendations be?
Absolutely. That's a terrific question. Yeah. I mean, the pace of model releases, especially the past 3 weeks, has been absolutely insane. I can tell you, everybody at Fireworks has not slept a lot in the past couple of weeks. Um, I think so. What I do, and of course, people have different methods, is the examples that I just showed. I basically have like my own eval set, right? So I have a couple of like prompts for specific things like reasoning, like general knowledge, like coding, like tool use that I always, whenever a new release comes out, I just test maybe with 5 to 10 different prompts and just get like a feel, even if it's not like the most scientific way. I just get a feel. Now, I know this is a shameless plug. Like the reason why I built the chat.fireworks tool was because before I had a Python script where I would have to run it and I would save it to a JSON, and you can just imagine it's a big mess. Whereas now it's a little faster because I just go there and I test it, right? So one is just like get a gut sense, a gut check of how good it is. If your gut check passes based on, let's say, your 10 prompts, then you can do a little bit more heavy experimentation. And for that, again, shameless plug, we do have like the Fireworks SDK. It's incredibly easy to just swap out models. It's literally one line of the model ID. And it's really quick to get started with just like almost like an A and B test script where you have this prompts and then you just test different models that you think are good with a specific evaluator and see how that performs. So that's like the second step, which is more. Now, after, if the initial gut check worked, that one worked, and you say, okay, this 120B model is looking good, maybe I'm ready for production, then maybe the safest thing is, of course, do more stress testing, but then only divert a very small percentage of your traffic into this new model, and then let it go wild, right? Like, not let it go wild, maybe that's not the perfect language, but see how it performs in the wild, rather, which is as you get real data out in the wild with your users in your product, see how it performs. And then once you have a couple of weeks of data and you see, okay, it's good, it's actually better, maybe it's faster, maybe it's cheaper, then you start to divert more traffic. So that's like the 3-step process I would recommend.
Yep, that 100% makes sense. Maybe I would just showcase this real world benchmarks that we recently
Mm.
released. That might be something very cool. Let me just pull it up. Do you want to talk over it?
No, go ahead, go ahead. You can definitely share it.
So, yeah, we recently published out our real world benchmarks, which is our way of benchmarking these models. And we had some interesting key takeaways from these models. So, the performance that you could see, like we saw the Quen 3 model, especially, were performing really, really well. So, that's something that we have published, and we'll hopefully continue to publish that, which gives you a more in depth understanding of there are so many different benchmarks that you keep seeing, but then how do these models really perform on real world use cases, right? Like, so we have tested them on some of the real world data sets and eval sets, and that's what we have published here. So some of the use cases that you can see here in the benchmarking is re-ranking and classification with e-commerce, instruction following, and tool use, etc. So these are some of the use case benchmarks that you could see, which will help you make a decision of which model stands where in terms of doing these specific real world use cases. So that's basically what we have.
I think it's also worth mentioning, we also released eval protocol, which is an open source,
Open that up.
open source tool that you can use to set up these evaluations, right?
Yep.
So that's a really powerful tool as well that you guys should definitely play around with. I think it got released maybe this week or a couple of days ago. So feel free to test it out, give us any feedback. Here, the idea, as well as Ash was saying, is we want to really speed up this process of going from experimentation to production in a simpler way, instead of having all these, dancing solutions where each time you have to write new code and script, etc. We're trying to centralize it into a simple to use dev tool.
Absolutely. So this is the eval protocol that Roberto was talking about. We have a detailed blog about it here. So if you're getting started with it or want to understand more about it, you can start with the blog. This is the tool. So if you want to get started, we also have some tutorials right here for like single-turn eval and multi-turn eval. So you can go and check out these code examples as well to get started right off the bat. But that covers most of the things that we wanted to discuss. One last thing, just to be mindful of the time. I know most of you are excited to just start building. I know you'll have a lot of use cases. Typically, when you sign up for Fireworks, you get $1 of credit, which gives you about 1 million tokens for you to run on different models and test out things. But as a special offer for the people who have attended this webinar, we are giving out $50 of credits. So if you want to test out something, just build a MVP on the platform, build a few pipelines for yourself. You'll need more than $1 to run those. So we're offering the $50. Feel free to scan this QR code and fill out the form. Within about like 24 hours, you'll get access to $50 of credits. Do make sure that you're entering your account ID. The way that you get your account ID is, so you basically go to fireworks.ai, click on login, and add your if you have not logged in or like you have to register for it, then you use a Gmail or your work email to log in. And then here you're going to see, if you click on home, you're going to see your account ID. So make sure that you copy this account ID and add that to the QR code form that's right here, and we'll issue $50 of credits for you to get started. Amazing.
Amazing. Very excited to see what people build.
Yeah. And if you have any questions, you know where both of us sit. So just shoot us a text on LinkedIn and we'll be happy to help.
Thank you. Thank you so
Thank
much.
you. Have a good one.
Bye.